Hello everyone, today I'm with you to explain a concept of solution of homogeneous partial differential equation. If you have not subscribed this channel yet, subscribe my channel to get more videos which I'm going to upload further. Also, if you like this video, don't forget to give like button in the YouTube channel. In the previous video, I have explained solution of non-homogeneous partial differential equations. In this video, we will discuss how to solve homogeneous partial differential equation. Let me explain this concept with the help of an example. Solve dou square z by dou x square plus z is equal to 0 given that when x equal to 0, z is equal to e power y and dou z by dou x equal to 1. This condition means when x equal to 0, z is equal to e power y and dou z by dou x equal to means when x is 0, z equal to e power y as well as when x is 0, dou z by dou x is 1. Let us suppose that z is a function of x only, because in this question you can able to see in the denominator independent variable, visible independent variable is x only. Therefore, we suppose that z is a function of x only. So the given PDE assumes the form of ODE, that is ordinary differential equation. Since in the denominator, that is independent variable is only one, visible independent variable is only one, we assume this as ordinary differential equation and hence we will solve it. Can you able to apply the previous method which we have discussed for homogeneous, non-homogeneous PDE? Is it possible by direct integration? No. Why? Because if you shift this z term right side, this will become dou square z by dou x square equal to minus z. So by direct integration, this is not possible because we don't know what is expression for z equal to. So integral of z is unknown, so you cannot able to use the direct integration method which we applied for solution of non-homogeneous partial differential equation. So we have to apply another method which I'll be explaining here. So given partial differential equation, let us assume as it is ordinary differential equation. So dou will convert to d. This will become d square z by dx square plus z is equal to 0. So this is the corresponding ordinary differential equation to the given PDE. Or this we can write d square plus 1 of z is equal to 0, where d is equal to d by dx. Now we know to solve this type of differential equation. So this is by writing auxiliary equation we can solve this type of differential equation. So auxiliary equation AE means auxiliary equation is d square plus 1 is equal to 0. That means d square equal to minus 1 or d is equal to plus or minus I. So if d is equal to plus or minus I, we know how to write the complementary function, or being it is right side 0 homogeneous differential equation. So we know how to write its solution. So solution of this ordinary differential equation, z is equal to c1 cos x plus c2 sin x. Because here d equal to roots of auxiliary equation is plus or minus I. So whenever complex roots we have, we know how to write the solution. Z is equal to c1 cos x plus c2 sin x. c1 and c2 are constant. Now we know that here actually given differential equation is partial differential equation. We assumed its ordinary differential equation. Since given actual differential equation is partial differential equation, here other than given independent variable x, other than x, y variable, we can treat it as constant. So in this solution, z is equal to c1 cos x plus c2 sin x. Constant term c1 and c2 we can write as function of y. Therefore, solution of partial differential equation, we write it as z is equal to f of y, function of y into cos x plus g of y, that is function of y into sin x. So let me give it as equation number 1. Now, if you find the expression for f of y as well as g of y, we will get the required solution for PDE. Now use the condition. So first condition is when x is 0, z is equal to e power y. So using this condition in given equation or equation number 1, we get e power y equal to, because z is replaced by e power y, f of y into cos x is 0, so cos 0 plus g of y into sin 0, which means f of y equal to e power y, because cos 0 is here 1 and sin 0 is 0. So if you substitute, we will get f of y equal to e power y. So we got an expression for f of y. Now we have to find g of y expression. To find an expression for g of y, so we can use the second condition. What is the second condition? Dou z by dou x is 1 whenever x equal to 0. Do we have dou z by dou x term here? No, we have only z expression, that is in equation 1 we have only z expression. So how to find dou z by dou x? Just differentiate this equation number 1 partially with respect to x, so that we will get an expression for dou z by dou x. Hence we can substitute the condition. Therefore, to use this condition, dou z by dou x is 1 when x equal to 0. Let us differentiate partially equation number 1 with respect to x. So dou z by dou x equal to derivative of z partially with respect to x is dou z by dou x. Derivative of cos x is minus sin x. So f of y is constant here since we are differentiating partially with respect to x, minus f of y into sin x plus g of y into derivative of sin is cos x. So this is what the dou z by dou x expression. Now let us use the condition, that is condition here it is dou z by dou x is 1 when x equal to 0, and this expression that is in dou z by dou x here. So what we get here, dou z by dou x is replaced by 1 and x is replaced by 0. So 1 equal to minus f of y into sin 0 plus g of y into cos 0. Since we know that cos 0 is 1 and sin 0 is 0, we get g of y equal to 1. So we already got the value for f of y. Here it is f of y is equal to e power y. Now we got an expression for g of y which is equal to 1. Substituting this in equation number 1, we will get the required solution. So that is z is equal to e power y cos x plus sin x is the required solution. Now let me explain another example. Solve dou square z by dou y square equal to z given that y equal to 0, comma z equal to e power x and dou z by dou x equal to e power minus x. So here independent variable is y only. So visible independent variable is y only. Condition is given when y is 0, z is e power x, and when y is 0, dou z by dou y equal to e power minus x. Since visible independent variable is y only, we assume it's ordinary differential equation. That is d square z by dy square equal to z. This is the corresponding ordinary differential equation of given PDE. Or we can write d square z by dy square minus z is equal to 0. Or z square d square minus 1 into z equal to 0, where capital D represent for d by dx. Now to solve this homogeneous ordinary differential equation, just it is enough to write the auxiliary equation. Auxiliary equation AE is d square minus 1 equal to 0, which means d square equal to 1 or d equal to plus or minus 1. Therefore, solution of ordinary differential equation is z equal to constant c1 into e power y. Here independent variable is y, denominator variable is y. Therefore, c1 into e power y plus c2 into e power minus y. Since in this partial differential equation, visible independent variable is y only, so x we will treat it as constant. So this c1 constant and c2 constant we will write as function of x. That is, solution of partial differential equation is z is equal to function of x f of x into e power y plus function of x, that is g of x into e power minus y. Now we have to find an expression for f of x and g of x, so which will give us full solution of partial differential equation. To find this f of x and g of x value, we will use given condition. So what is the first condition given? When y is equal to 0, z is equal to e power minus x. So let us use this condition to obtain expression for f of x or g of x or some condition. So using this in equation number 1, z replaced by e power x, f of x into y replaced by 0, so it is e power 0, plus g of x into e power minus 0, which means here e power 0 and e power minus 0 is 1. So this means f of x plus g of x is equal to e power x. Let me denote it as equation number 2. So we didn't get any value for f of x or g of x, but we got an condition in terms of f and g. So now let me use another condition which is given. What is that? Dou z by dou y is e power minus x when y equal to 0. Do we have dou z by dou y expression here anywhere? No. So how to find dou z by dou y expression? It is just enough to differentiate equation number 1 partially with respect to y. So dou z by dou y is equal to f of x into derivative of e power y is e power y minus g of it is actually plus g of x into derivative of e power minus y is minus 1 into e power y. Therefore, dou z by dou y is equal to f of x into e power y minus g of x into e power minus y. Now use the above condition, that is dou z by dou y is e power minus x when x y equal to 0. So applying the condition, dou z by dou y replaced by e power minus x, which is equal to f of x into y replaced by 0, that is e power 0, minus g of x into e power 0, which implies f of x minus g of x is equal to e power minus x. Let me denote it as equation number 3. Now in equation number 2, we have f of x plus g of x is equal to e power x, and equation 3 we have f of x minus g of x is equal to e power minus x. If we solve these two equations, simultaneous equations, we will get an expression for f of x and g of x. For that, let me add equation 2 and equation 3, that is equation 2 plus equation 3. Left side, f of x plus f of x is 2f of x and g of x plus minus g of x is 0. So left side remaining only 2 into f of x equal to right side e power x plus e power minus x. So it is 2 into f of x equal to e power x plus e power minus x. Or let me write f of x as e power x plus e power minus x by 2. We know that this is, that is e power x plus e power minus x by 2 is nothing but cos hyperbolic x, that is cos hx. Therefore, we can write f of x as cos hyperbolic x cos hx. So we got an expression for f of x. Now we have to find an expression for g of x. To find that, let us subtract equation number 2 and equation 3. Subtracting equation 3 from equation 2, that is equation 2 minus equation 3. So we get left side f of x minus f of x is 0 plus g of x minus minus of g of x, that is 2 times g of x is equal to right side e power x minus e power minus x, or this we can write it as g of x as e power x minus e power minus x divided by 2. This means g of x equal to, this is the definition of, that is e power x minus e power minus x by 2 is the definition of sine hyperbolic. Therefore, g of x is equal to sine hx. Now we got an expression for f of x as well as g of x. Substitute this in equation number 1. We will get the solution for this given PDE. That is z is equal to cos hx into e power y plus sin hx into e power minus y. This is what the solution of given partial differential equation. This is the way how to solve the homogeneous partial differential equations. Thank you for watching.